Okay, so part 2 of Module 3, we're going to get into object-oriented programming. I'm not going to lie, this topic is pretty complex, but we're going to touch the surface here in this video, and then I'll answer any questions, go into a little bit more detail when we have our synchronous portion of the class next time. So object-oriented programming allows us to structure our programs around these behaviors or real-world things, and we group those together into what we call objects. And so you can think of taking a real world entity, say a robot, and we can create an object based around that robot. And we can have, say, all robots that we're using drive. All robots have wheels. And so those objects, which is the robot object, have characteristics that are similar. And we can create these objects to either have those similar characteristics, or if we want to then refine, now we have a off-road robot, we have a road-based robot, and it might have some different characteristics, and so we can create those, we can refine our objects. And we do all of that in something called classes. So a class will always have behaviors and characteristics. So, for example, we can have a robot class, and that robot class might have, characteristic wheels, sensors, and then it can also have behaviors. So it can drive, it can sense. And maybe we have a number of different kinds of robots, but they all have this base functionality. They all have wheels, sensors, the capability to sense, and the capability to drive. And then we can, like I said, refine that, and then maybe my off-road robot, and again, make sure those are capitalized for classes. It might have everything that robot had, but then it might have, shocks. It might replace wheels with bigger wheels. And so this idea of object-oriented programming allows us to have this base class that we can then take the behaviors and characteristics and abstract that to different kinds of robots. So we still have that robot sitting here. So it still has wheels, sensors, the capability to sense and drive, but this off-road robot now has shocks. Maybe it has climb capability and stuff like that. And so that's kind of what object-oriented programming really means. So let's go into a lot more detail and dive into this. So before we get into too much detail, so there's a site here. If you have the time, you want to read about it. That's where I grabbed most of this information, but it does go into a lot more detail. So we talk about these classes, and that's what these objects are based on. And the way Python works is in this idea of namespaces. So a namespace is basically gives us a name for our objects. So if I wanted, my robot is from the robot class. Now my namespace lives within this my robot. And my robot has all the functionality of the robot class, but it has unique functionality. So my robot wheels may be different than your robot.wheels. And so that is this concept of namespace. It allows us to kind of have characteristics given to my robot object that then belong to that object. And that allows us to kind of create all these different namespaces and functionalities and do things to one robot to another robot, and without changing all of the things together. Like I said, it's kind of abstract, but once we get into an example, hopefully it'll start making a lot more sense. But my robot wheels, and if we had your robot, and your robot wheels would be completely different than my robot wheels. And that's this concept of namespace. We can do that with functions as well, so you can have a function that belongs to my robot versus your robot, and they do different things. It also allows us to have different files with the same functions that we can then use separately as well. So let's talk about attributes real quick. So these are just kind of giving you some of these keywords, so namespace and attribute. Attribute would be .wheels. Wheels would be an attribute of my robot object. And like I said, this wheels, while the same variable, are very different attributes. So my robot's wheels versus your robot's wheels. So let's take a look at this example here, which kind of gets into what scope means. So we said we had these namespaces, but within a file we have different namespaces. So for example, this here, this function is its own namespace, while this out here is a different namespace. So we can have the same variable sum both here and here, but they have very different, they're not the same. So for example, if I have sum equals 4 here, I can reset sum to, we're not really resetting, this is a new variable altogether, sum equals 0, and then I count through here, so I'll go 0, 1, 2, so 3 times, and I'll add 2 3 times, so that should be sum plus 2, so that's 0 plus 2, and then 2 plus 2, and then 4 plus 2, which equals 6. And so if I return this sum here, test function will return 6, so test becomes 6 because of this sum loop. And if we print test, it'll print 6. But then we still maintained this sum up here, and that is a different scope than the sum within the function. And so now if we print sum again, we're not going to print 6, even though that's what sum equals here. We're going to print 4 because of the different namespace. So we can see sum is defined in 2 different scopes, one with the test function and one within main. So main being the kind of main function we're using there. So that becomes important when we start working with classes and this object-oriented programming, because it starts getting pretty complex and you want to access something and you have to know what scope are you accessing it in and what would the value be. So let's take a look at a little bit more complex example. So we have a function called scope test, and within that function we have some subfunctions, and then we have a couple calls to these functions, and we're looking at this spam variable. So let's take a look at the spam variable. So we start off and kind of think of this as the main portion of the scope test here. So we set spam to test spam. And then up here we call it, or so then we call this do local function, which sets spam to local spam. So after doing those 2 assignments, so we have spam number 1, spam number 2, we want to print what spam is. And depending on the assignment, it's going to do different things. So if we take a look, this print spam here is actually going to print test spam, test spam, instead of local spam because this spam is within the scope of do local. And so we are printing spam, which is in the in the scope test, and so it's test spam. So now let's look at a non-local spam. So what we're able to do is overwrite spam in this sense. So we can take that non-local spam and overwrite spam to non-local spam. And so now if we print spam, we're not printing this one anymore because we've overwritten it. We are now printing non-local spam. Because of the namespace, or the scope, sorry. So it's gone up one scope. Global spam is another scope level up, so that would be at the highest level, which is this level here. So even though we've now updated spam to global spam, that's a different spam, and I know this is really confusing, than this spam here. So this is again non-local spam. And if we come all the way out here to global scope spam, we have our global spam. So let's think about it this way. We have our local scope. Local would be the same scope that you're currently in. So that's would be this guy. This is a local scope, and this is a local scope. So when I go and print spam here, I'm printing local spam, which in this scope is this guy here. Now if we go to non-local spam, what that is just saying is one level up. So this non-local spam is actually overwriting this spam. And that's why here, when we print spam, we get non-local spam. Global spam is printing the main level spam. I'm tired of saying spam at this point, which then gives us this spam way out here. So that's why even though we've overwritten global spam, we did not change this scope test level spam. And so that stays non-local spam. But when we get out here all the way to the outer global level, we are in global spam. Confusing, I know, but if you have questions about this, we'll go into it again tomorrow when we look at the lecture. All right, let's get out of that and let's get into a little bit more concrete stuff. So again, let's look at the syntax. So class and then uppercase. Like I said, you can do the camel case or underscores. I like underscores, that's just me. What we have here is a class variable and then a class function, f. Whenever we call a function within a class, we have to pass self. That's the object. That's my robot. So I would be passing my robot to that class. And then now if we create my class, it has two attributes. It has that class variable and that class function. So let's create a version of my class, and we do that by this just assignment. We can see here that there is no init, so there's no initialization, so we do not put anything in there. And so now X is an instance of the myClass class. myClass. Okay. We typically do have an init function, and we'll see that in the example, but we will typically always have an init initialization. So always, again, we always have self passed to the functions. So for example, X, that object would be passed to the init, and then name. So again, you can set that equal to something as a default, and then that would be overwritten down here when I actually input a value. So self.data is just initializing a instance variable. So these are called instance variables. We'll talk about what those mean in a second. But we're just initializing data to an empty list, and then we're initializing name, self.name, to the actual name that we're inputting, whether that's a default here or an input to the instantiation of the class. All right, so instance objects. So again, X is an instance of my class. It has instance variables, which are these self.data and self.name. So data is an attribute, is a data attribute, whereas F is a function attribute to X. And we can call X.F, and that's going to print hello world. All right, let's take a look at an example. Let's create a class of dog. So we have a class variable shared by all instances of that class called kind. So that is a canine for dog. When we initialize the class, we're going to ask for a name and then again that instance of the object. So here we have two different instances of the dog class. We have Fido and Buddy. They share the same class variable kind, so both of those result in canine, but each one of those has its own instance variable name unique to each instance. So if we did d.name or e.name, we see we have Fido and Buddy. So let's look at a quick caution. If we do something along these lines with a class variable tricks, we would have an issue because if we have our two instances, we have Fido and Buddy. If we add a trick to Fido, and then we add a trick to Buddy, because this is a class variable, and if we look up here, class variables shared by all instances. Now, if we look at Fido's tricks, we have both tricks. And if we looked at Buddy's tricks, we would have both tricks. So depending on your goal, you would want those tricks to be an instance variable. And now, if I add trick rollover to Fido, and I add play dead to Buddy, those are only attributes of those instances of the dog class. So this instance, its attribute tricks only has rollover, and this attribute tricks only has play dead. So that goes again into some of that scope stuff. So when we say we have a instance variable versus a class variable, those are very different scopes. All right, so let's go into a little bit more detail and let's talk about inheritance. So this is what I was talking about in that concept with the robot, and then having that robot have different attributes, and then you have a maybe an off-road robot which has some of the same attributes as the robot, but then it has more stuff. So let's talk about person and a student. So every student's a person, not every person's a student kind of idea. So let's start with person. So every person has a first name and a last name. Those are instance variables, instance attributes. And then if we want to have an instance function, we'll just print the name. So we can create a person. We can just have, for example, me equals person, first name, captain, last name, buyer, and I can then call my print name and that is going to, all it takes in is self, and so you don't have to actually put anything in there. When you put the instance of the object with the function, it automatically places that self within that function. And so that's going to print then, it's going to print Captain Buyer. And if we had you, we could do another person, and that could be Colonel Neff. And now if we did the same function, it's going to print a whole different result, because this function is part of the scope of the y instance of the variable, and that's going to print Colonel Neff. Okay, so that's basically, we've seen that already. Now let's get into the inheritance. So we can see here, student class inherits the person class. And so that means everything that the person basically is added to the student. But we did something unique here, and the first thing we did was we overwrote this, overwrites this. So instead of, when I call the student for the first time here, instead of calling this init, it's going to call the student init. And we can see that we have first name, last name, and now we have a student year. And what is this? So since we have student inherits person, we can use these functions, even though we've overwritten init with this super, because we've changed the scope. So now instead of this scope being our functions, this is now the scope of our parent function, which is person, sorry, parent class, which is person. So now we can go and grab this function and use that in here. Or sorry, right here. So basically we're calling that initialization again. So we're setting our first name and last name. And then we set our graduation year. Then we have a new function, welcome, and we can print welcome self.firstname, self.last name to the class of graduation. We could potentially overwrite print name if we wanted to do something different. We could use print name, so we could add so student. Oh, sorry. So let's just go here. So when we create this instance of the student class, we have our first name, last name, and year, and we can still use all of this stuff because we have an inheritance to the first name, last name. The only reason we have to use super here is because we're overwriting this init, and so we just need to tell the class that, hey, when we want to use this init, we're actually using the parent class. And so now when we call welcome, it's going to say welcome Brandon Kim to the class of 2023. And if I did x.printName, I can still use that function, and that would get us, Brandon Kim. Okay, last thing we're going to look at is private variables. And we take a look at private variables because it allows us to kind of protect some of the data within our classes. So for example, I set x to Brandon Kim. I could take x.firstName and change his first name. If I didn't know what I was doing, I could change it to Jim. I don't know why I spelled Jim that way. Jim. And now Brandon's name has been changed to Jim. But sometimes you don't want that to be possible. So private variables, which is pretty much a concept for most languages, allows you to protect those variables. However, Python does not do private variables. So even though I can say, hey, first name is a private variable, I can still overwrite it. It's more of an idea of just kind of convention. So this first name should be protected by those who are coding Python should know that if it's 2 underscores, I should not do something like this. And that's kind of the only protection we really have. Other reasons to do this is, say, for like the coordinates of a robot to where to go. Say I want to tell my robot to go to 3, 3. Well, I want to be able to check that 3, 3 is within the bounds of my grid. And so instead of saying, robot.x equals 3 and robot.y equals 3, that provides no protection because I can just write those. I would set robot.setCoordinates to 3, 3, and then within that set coordinate function, I would have protected x coord equals x and protected y coord. Well, what I would really do is if x within bounds and then if y within bounds, and that allows you to then set those variables but within bounds so that you're then checking that. Here we're not checking anything, we're just setting it, and that kind of defeats the purpose of having some kind of limits that you want. Whereas this set coord, and again you want these 2 underlines, to kind of indicate that x is a private variable, and same with the y here. And that just kind of limits then your functionality and making sure that your robot doesn't go off your grid or into a wall or anything along those lines. All right, that is the gist of classes and object-oriented programming. It's a lot for 27 minutes. Typically in a class based on C++ or Python or Java, those different object-oriented programming languages, you spend a couple days, a day on probably each of those topics, but we'll have time in the synchronous portion to go through some of that, and we'll take a look at that and answer any more questions that you guys have. And then we'll have the in-class exercise, which will show exactly how we're going to use these classes with ROS.